I have some very bad news for all of you Kubernetes users. Ingress, out. Service Mesh, out as well. At least when specs are concerned. Or to be more precise, they're not out, but they are on a way to be out of Kubernetes and replaced with something else. So, if you have emotional attachment to any of those, to Ingress or service meshes, start the grieving process now, because here comes Gateway API. Gateway API is a collection of resources that model service networking in Kubernetes. It is role-oriented, meaning that its API resources model typical organizational roles. It is portable, meaning that its specification is supported by many implementations. It is expressive with header-based matching, traffic weighting, and other capabilities that you hopefully learned to love in service meshes typically. And finally, it is extensible. Providers can still extend Gateway API to support their own specific features, those that are not included in the original specification, even though the specification itself allows pretty wide range of features and use cases. What matters is that the Gateway API spec is not yet another futile attempt to standardize something, like many of those before that failed miserably. It is supported by Contour, Emissary Ingress, Google Kubernetes Engine or GKE, Istio, Kong, Traffic, and many others. Now, let's see it in action. First, get familiar with it, and then we'll talk about it more further on after a short demonstration of how it works. There are three distinct components in Gateway API specification. There are gateway classes, gateways themselves, and routes, a few different routes. Let's start with the first one, the gateway class. And what is it? So it defines a set of gateways that share a common configuration and behavior. It is similar in a way to Ingress class or storage class. So the expectation is that a provider of your Kubernetes distribution will provide gateway classes just as it provides storage classes, or that you'll choose one of the existing projects like Istio or Kong or Traffic. More often than not, you should expect in the future, if not today, gateway classes to be already baked into your Kubernetes cluster, and then you can replace them with other classes if you feel to do so, just as you can replace baked-in storage classes with some others more efficient if you don't think that those are enough. So most of the providers of gateway classes are either providers of managed Kubernetes services like AWS, Azure, Google, hopefully all three, or providers of solutions for Ingress or service meshes, like Traffic or Nginx and so on and so forth. Those are the same players that are currently, one way or another, involved in networking, but now under the same umbrella of the same class or specification. Now, let's see it in action. But before we do, as always, there is a link to the gist with all the commands that I executed while preparing for this demo and those that I'm going to execute now. So if you want to reproduce what I'm doing, you can. Now, I will skip the first step of installing gateway class and everything around it simply because today I'm using GKE, Google Kubernetes Engine, and GKE already supports Gateway API out of the box, sort of. The only thing I really need to do is to install the CRDs themselves. CRDs are just definitions. They're not doing anything. They're not performing any actions. And you'll see what happens then. So I'm going to execute kubectl, apply. I'm going to use customize and point to the GitHub repository that contains all the Gateway API CRDs. Then I'm going to wait for a moment or two. You'll see why in a second, but waiting. There we go. I'm going to execute, that was enough, right? I'm going to execute kubectl get gateway classes and see what did I get. And the output is two classes, right? we have two classes provided out of the box by GKE. You should see different classes in other providers, just as you see different storage classes in other providers as well. So what happened is that Gateway API was not installed in my cluster, but the moment GKE detected that I created or installed the CRDs, it installed the classes that I need, all the definitions, the whole Gateway API, which is pretty awesome. It would be even better if I didn't need to install the CRDs, but this is the second best option I can hope for. Now, regarding those two classes that I got, you're going to have different unless you're running GKE, using GKE. I have GXLB, which is Global External HTTP or HTTPS Load Balancer, and there is RILB, which is Internal HTTPS Load Balancer. I'm going to use today global one because it sounds better, right? Now let's move to the second type of the resource, which is Gateway API gateways. What I got so far are gateway classes. Let's see gateways themselves. But before I do, I forgot to mention that gateway classes typically are something that providers provide, whomever the provider is, and we are yet to see who is responsible for gateways. Now, a gateway describes how traffic can be translated to services within a cluster. It might create external load balancer, depending on the solution you're using. It might be used for internal traffic. It can define network addresses, and through listeners, which we are going to see in a second, it can define host names and ports and protocols and terminations and TLS and so on and so forth. Gateways are typically created by cluster operators. So that's a second persona. Provider gives us classes, gateway classes. Operators typically, not necessarily, install and set up gateways themselves. So they're in a way similar to ingresses. So let's see in action. Let's see a definition of a gateway. So cat gateway YAML, and over here we have a gateway resource. I'm calling it HTTP, and in specification there are two important sections. One is gateway class name, which I'm using to say, hey, I want to use this specific gateway class, in my case global gateway, and I can have one or more listeners. I'm having only one, that's enough for the demo, and that one is called HTTP. Protocol is HTTP because I do not have certificates for this cluster, and the port is going to be 80. Now let me apply that manifest by executing kubectl. I want to apply it in the production namespace. It is namespace scoped, even though resources from other namespaces can use it if we allow it, and I'm going to apply whatever is defined in gateway YAML. Now, before we proceed, ignore those silly warnings from Google. I need to fix it, but not for this demo. So whenever you see this warning at the top, just ignore it. Now you will notice that the address and the ready field is empty. That's because the gateway now needs to do some work. And in this specific case, among other things, it will create external load balancer through which I can send requests to my cluster and then let Gateway API forward those requests wherever they should go. So I will wait patiently for a moment or two or three, who knows? And then I'm going to execute kubectl, namespace production, get gateways again. And this time we can see that I got an address. I got an IP of the external load balancer through which I can send requests to my cluster, and then you will see what happens then in a second or two. Now let's go into the third component, which is routes. Let's see that's the missing piece. That's really where you will spend most of your time. Routes are where most of the magic happens. They define protocol-specific rules for mapping requests from a gateway to Kubernetes services. A route can be HTTP, it can be terminated HTTPS, TLS, TCP, or UDP, at least today. Those are the options we have. Now, the interesting part is that this is typically handled by a third persona, right? Routes are usually created by application developers, or at least that's the idea. And from that perspective, they are similar to service meshes. So let's take a look at one silly, simple route So let me output with cut, customize overlays, simple route.yaml, and we can see that I have the kind of the resource which is HTTP route. Unlike gateway classes and gateways, routes can be different kinds. I have a name, that doesn't matter really. What does matter is spec. And there are three sections here that matter. First is parent references, and in this case I'm referencing the gateway called HTTP. I could reference even multiple gateways, which doesn't make sense in most of the cases, but who knows. Then I have host names. In this case, only one host name, which is silly demo, the IP of my load balancer, and nip.io, because I don't have a real domain for this demo. But what matters here is that this is the address, this is the host name that will be accepted by the gateway and forwarded somewhere, wherever that somewhere is. And where that somewhere is defined in rules. And in this case, the simplest possible, I'm saying, hey, the requests coming from that host should be sent to the backend with the name silly demo and port 8080, and that backend is effectively the service, the service from the dawn of Kubernetes. Now, this specific definition is not really much different from what you would expect from my Ingress resource. It does more or less the same, so there is no difference except that this time we have a standard interface. We actually had a standard interface with Ingress in the past as well, but Ingress is very limited. We're gonna talk about it later. That's where service meshes come in. But for now, what I'm showing is very, very similar, at least from the operational perspective, to an Ingress. So let me apply that manifest with kubectl. Namespace is production. I want to apply whatever is defined in that customized directory, and my route together with the rest of the stuff that I have for a silly application, a silly demo, is created as well. I have a service deployment and the route itself. No Ingress. I don't need Ingress anymore. Ingress out. Now, I could send a request to my application and confirm that it works, but it will not work. It will not work because it takes a bit of time until the routes are assembled and everything works. At this moment, typically half a minute, but remember, this is a very, very early implementation of Gateway API. It will probably be faster. Anyways, no point testing it out for a while, and I will use the time to tell you a very important message. Are you ready? Yeah? Okay, you need to like this video, you need to subscribe, you need to join if you can, and if you work for a company, tell your boss to sponsor this channel. That would help a lot. So, after this inspirational message, let's see whether I can access my application. I'm going to send a CURL request to silly demo, whatever is the Ingress host, and nip.io, and the response is what I expected, just as if I used Ingress. I'm getting a response coming from external load balancer into my cluster, and then instead of Ingress Gateway API, forwarded it to the specific service attached to a specific pod of my application. And I'm seeing this is a silly demo version 107. Now you might say, hey, this is great as a standard. I love it because people are trying to standardize things, but is there really a reason to switch to this from Ingress? Are you getting anything? And from what I showed you so far, we are not getting anything. But let me jump into a slightly more complex example, and then you can see that actually it's much more than Ingress. So a more complicated, more complex example, what can I do? Let's do Canary deployments with Gateway API. Let's see whether that would work. I'm just going to execute kubectl apply with the namespace production and the specific directory where I have stuff, more complicated stuff, more interesting stuff. You can guess what it is. I'm not going to say, but check the name of the directory and you will know what it is. Actually, I already said it. It's Canary deployments. Anyways, what happened now is that besides the application that I was already running, I deployed a second application, a newer release of that application in parallel. So I have two services, two deployments, and one route, one HTTP route that was slightly changed. So what's the effect of that? Let's see. Let's send the same request as before, CURL, silly demo, Ingress host, whatever it is, nip.io, and the response is still, this is a silly demo version 107. So nothing really happened. Well, something did happen, and I can demonstrate that through a different CURL request. This time I'm going to add header that says type is Canary and then to the same address as the previous request. Just this tiny special header injected into it. And the output is still, this is a silly demo 107. This is silly. Nothing special is happening, but that's because the reconfigured route that I'm going to show you in a couple of moments is still not operational. It's slow. That's a downside, but that's a downside of very, very early implementation. It's not slow how it works, but it takes a bit of time until it kicks in. So I'm going to re-execute that same request, resend that same request one more time. And this time I'm getting, this is a silly demo version 108. So what is happening with my application is that whenever I send a normal request to it, I'm getting the response from the old release. And whenever I send a request with certain things in the header, I'm getting a response from the newer release. Both of them are running in parallel, and Gateway API is making sure to forward the request to one place or another. And how did I do that? Well, let's take a look at the route that I applied a few minutes ago. Now the top part is exactly the same as it was. The bottom part, the second backend refs, is also the same. What is changed, what is different, is in the middle, in the first rule that says, whenever there is a matching header that has exact value with the key or the name type set to Canary, then do not send to silly demo, send it to the service silly demo Canary. And that's where the logic is happening. That's where I defined what should go where. Now you might say, hey, this does not look like Ingress. Now this looks like service mesh. Of course, because service mesh was created because Ingress couldn't do the things we needed to do, but then service mesh became a nightmare because every single implementation of service mesh came up with a different syntax, different API, which is horrifying. And now we have Ingress and service mesh put together into a single API that does not depend on the implementation. I would have exactly the same or almost the same manifests even if I did not run GK Gateway API. If I used Kong or Traffic, my definitions, my manifest would still be the same. The only difference would be in the name of the gateway class defined in the gateway itself. Now, I'm not trying to say, hey, this is how you should do Canary deployments, because that would be silly. You should still use Flagger or Argo rollouts. Both of them are available in different videos. If you're not familiar with Flagger or Argo rollouts, check them out. They're awesome. I'm not saying, hey, now suddenly with Gateway API, we can define directly in Gateway API all those different things. Some things we should, some things should be managed by other applications. And in case of Canary deployments, which is just one of many, many features of Gateway API, we shouldn't use it directly. We should rely on other tools like Flagger or Argo rollouts. Now, the good news is that Flagger is already working on integration with Gateway API. It's in public preview and it should be available stable relatively soon, I hope, and Argo rollouts will hopefully follow very, very soon. And that's a trend you will see with the tools. The more Gateway API becomes adopted, the more the tools will be using it as well, and it will become some kind of golden standard, and it will force you into using it. Not that there is a need to force you into using it, because it's absolutely awesome. Who doesn't want standardized API? Now let's talk about Gateway API pros and cons. So what can we do with Gateway API? Well, we can do more or less all the things that we were doing in the past with ingresses and with service meshes, except that this time it has a standard API. We can do redirects, rewrites, traffic splitting, cross namespace routing, upstream and downstream TLS, TCP routing, and so on and so forth. So you should be able to do all the things you normally do with either ingresses or service meshes or both, but this time through a standard API. So what are the pros and cons? Let's start with negative things. And there is only one con, one negative thing I can think of, and that's that the implementations of Gateway API are very, very early. At this time, at this moment, September 2022, there are issues related to specific implementation, but that's normal given how green they all are. This is a new spec, new standard, and implementations just started emerging, but I bet that in no time we will have a bunch of implementations, many of them stable and usable in production, if not already. So that's the only negative thing, if we are early in the process. Now, positive, well, there are quite a few positive things. I will not list them all here, but only those that really, really matter, at least from my perspective. And the most important one is that we have finally standard API spec for more or less everything related to networking. Implementations will differ, and that's great because you can pick and choose which gateway API implementation matters to you the most, but the specs are going to be the same because Ingress specification is just too limiting, and then implementations of Ingress spec ended up forcing you to use a bunch of labels which make no sense, and service meshes are a complete mess from spec perspective. Each of them is completely different. There was an attempt, SMI, used mostly by Linkerd, but that never really became any sort of standard. So it's a standard API specification, which is absolutely amazing. The second is that this does not happen really very often, and that's that most of the industry, at least all those players somehow involved in networking in Kubernetes, are behind this spec. Everybody is on board, which is great news. And finally, we have separation of concerns. It is very clear what are the things that the provider should do, what are the things that ops or sysadmins or SREs or whatever those roles call themselves today should do, and finally, what should be left to application developers. And that separation of concerns is really a good thing because it's finally clear who does what. Now, the only thing left is to see where that spec goes and how fast will the implementations follow. I can place a bet that it will be extremely fast. Right now, which is September 2022, we have implementations from Acnodal, Epic, I don't know what it is, but it's there. Apache API 6, which is in alpha, Cilium, work in progress, Contour, alpha, Emissary Ingress, or Ambassador API Gateway, also alpha, Glue Edge, work in progress, Google Kubernetes Engine in public preview, HA Proxy Ingress, also in alpha, HashiCorp Console, not sure what's the status, Istio, Alpha Kong, Alpha Kuma, Alpha, Nginx Kubernetes Gateway in pre-alpha, and Traffic in alpha. So it's very early, but everybody's moving fast. That's a good thing. Further on, we already have integrations with Flagger, which I mentioned previously, and Cert Manager, my favorite manager for certificates. All in all, it's a great start. Ingress and Service Mesh specs are about to go extinct and be replaced with Gateway API. Thank you so much for watching. See you next time. Cheers.